Welcome to a new test and teardown video. This time it's a PM5509 PAL TV Pattern generator. It's from 1974. And everything in this one is done by counters and gates and timing and all sorts of funky stuff. It can do 5 different patterns in black and white mode and 5 different patterns in color mode. But what I recently learned by reading the manual is that you're actually allowed to click in more than one of the test pictures, and this way you can combine test pictures, right? But when you got buttons that works like this, right? Why would you figure out you're able to do this and add the circle to the checkerboard? Isn't that funny? But you can. And you can actually add all 5 of them, so they kind of add the picture and then it's just added. It's really weird, and you can do this in color mode as well. Really funny. This one is not only a PAL video generator, because we got a video output here, but we also got RF output. So it also consists of a TV modulator, 5 different channels. So those 5 buttons here, they select 5 different ranges, and all of the ranges, they can be programmed to whatever TV channel you want just by dialing the little pots here. And you can even modulate sound into your picture, so you can test TV sets and all kind of stuff. It's just amazing. And you can also put in external video and then select internal video generation or external. Have it out of this the same video output. And you can of course have a trigger for your scope if you want to analyze stuff. It's nice to have a super good and stable trigger. Chroma is the color burst level of the color burst actually. So that's actually also turning on and off the colors, or how much intensity in your colors you want. I'm gonna go and show you this, so you can take a color picture and make it into a black-white picture by turning down chroma. So that's actually turning down color burst. RF amplifier, RF level here. That is of course just a variable attenuator on the RF level for your TV set. I spent the last few hours repairing this unit because of course it didn't work, and I needed this unit for a TV set repair, of course. So I'm going to show you all I've done to this unit. So taking off the sides is quite easy. All you have to do is take away the handle, and then the sides just flip away. The same screw is used to hold the sides. That's kind of all there is to it. This is the amplifier for the TV signal. So a tiny little amplifier module here on the back, and that is kind of all there is on this board. There's a power supply for the amplifier. And here on the back, it reveals this is the G04 model of this unit. So we've got DC bias for VCR for incoming video, and of course audio input output. And what do you know, 2 Philips professional service stickers. So this unit was definitely repaired in 1979, last repair, where they kind of did it the right way, and then there's another one where it went to repair the first time. Isn't that funny? And of course it is adjusted for 230, so that's all super nice. And the other side here was also a board full of all the fantastic stuff. And you can release those 2 screws and then flip this board out for good service. There it's hinged over here. So that's all super nice. Very, very service friendly unit. And here in the bottom, we see the mains transformer. We see the bottom side of the main logic board. And this board contains a lot of stuff. Timing, all the different sync pulses, counting all the lines. As you can see here, we got tons of counters and trigger on this and trigger on that. It's amazing how this is done. I should probably stick in a few slides from the manual so you can see the block diagram, how this is all the timing and all that kind of stuff. And this is the color burst crystal. And this is, of course, all the color modulation and all that kind of fancy stuff that is here on the side. And all that stuff is absolutely working perfectly fine, so I didn't poke around with that at all. What I did poke around with... Yeah, manual, yeah. Oh, yeah. Somebody's impressed. Yeah. So this board comes out all by 2 screws here, and then you just lift it back like this, and then take it back and then flip it up. So here's the board, and then you take it up here, and look at that. We don't have hinges, so that's actually the holders, the 2 threads for the screws. But then, as you can see here, you stick in the board like that, in this little groove, and then it's difficult to do with one hand, right? And then it kind of stays like that, super service friendly, yabba dabba do. Now you can measure here and solder here and poke out components and do whatever you want, and it's still fully operational. What I actually did is, originally the 2 blue wires for the 2 meters, they were very, very short like this and had a little connector, and here was, of course, the mating part of the connector of that on that board. So the problem was you can't see what the meters are doing, so that's a little bit annoying. And because this is channel selection and channel fine tuning and all that kind of stuff, so of course you want the meters to work. And this is just super simple DC for the meters, so those wires can be as long as you want. It's not a big deal. So, and here is the yellow wire. That's also a low frequency signal of no big importance. And that one was soldered in very, very short. So you need to desolder that to connect or flip this board. So, of course, I modify that with a new yellow wire. And then, yeah, I changed the 2 capacitors here. They were kind of dodgy, or they were the same kind of type as some other capacitors, and I found a few of them, like here, being bad. And when those are bad and they are on the voltage rail, I mean, it's the same type, so I kind of hunt down the same type and then I change the same type. And here's in the analog stuff, so I changed those as well because I thought they were just as bad as the other ones, so why not? So here in the power supply of here we have all the power supply parts for the circle generator. The circle generator is amazingly advanced. Can you imagine? This unit is a raster TV picture, so it's scanning the TV pictures line by line, and then imagine having a generator drawing a circle in this raster mode. Just think about it for a few minutes before you go to sleep and try and figure out how to do this completely analog with only a few transistors and pot meters and stuff like that. And, well, some counters triggering this and triggering that. And it's, wow, that is amazing. I should definitely put in a few pictures from the manual where they explain about that circle generator. And Yes, of course, the circle generator was causing a lot of problems. So I tried to change all those capacitors, and it did improve quite a lot. But it's still funny, unstable. Every time you select this the circle generator, it takes a minute for the circle to get to the correct size. So why is that happening? I actually don't understand. It should take only one frame for this to be stable. So I don't understand that exactly. Yeah, about the power supply, it was running very warm, and it got unstable. And maybe it's just because the design is a little bit stupid, because it's running off -5 and +12. So that's actually all the logic and everything here is running on -5, and all the analog stuff is running on +12. And that's the only two power supplies for almost everything, except for a 48 that is cranked down to a 30-something for the TV generator. So that's running off a positive high voltage. This is a Zener diode for that voltage, and then that voltage goes to those potmeters, and those select the different potmeters that goes to the channel generator. So that's quite simple. Yeah, back to the transistors in the power supply. They are running like insanely warm, and that heat was maybe affecting the two regulator chips for that transistor, causing unstable power supplies. So I thought, could I just poke out all this entire circuit and put in a 7905, and here I could put in a 7812, and then we will be done. But I thought, hey, let's just keep this design as original as it is, and just take the 3 wires for the NPN transistor, and then put the NPN transistor on the rear plate. That plate is a 3mm thick aluminium plate. It's covering the entire rear side. So why not put that transistor that was running insanely warm? They had actually a little metal heat sink here, but it's like 2 by 3 centimeters. It's just way too small for this kind of power. So this one was running 100 Celsius. So of course it heats up this one, and that one is funny enough, very sensitive to heat. It's the same problem with the 12 volts. But here I didn't want to drill any more holes in the rear, or actually reuse a hole that was already there. So what I did here is I just used a hole on the sides that's already there, and then I put in the original transistor here. And what do you know? They're almost ice cold now, because all this metal is like 100 times better to cool down. This, it's just 5 watts or something like that. But imagine 5 watts in a like 2 by 1 little aluminium bent thing. This 12 volts here actually had a half the size heatsink. It's absolutely useless design. So of course this is a very good solution, and now it's running super cold. The rectifiers, they only get finger warm. So that is not a problem at all, and it's really nice and stable now, and I'm super happy. The only thing that runs a little bit too hot, if I might add this, that will be the video output amplifiers for the 2 different video outputs, the one that goes to the VCR or the one that goes to the output jack here, B and C here on the front. It's actually 2 different video drivers with those 2 resistors, and those 2 resistors, they are, I think it's 90 Celsius. So it's only a resistor, but it's very close to a capacitor and the transistors. So of course this is going to have a limited lifetime in this area. So if you have a unit like this and you're missing video output, go and have a look in this area as well. Definitely search down hot areas, and everything else is absolutely nice and cold. So how about we power this up and let me show you how it works. And of course we're gonna go and get some power on. I'm gonna set a tiny little video monitor, just a tiny little headrest video monitor that I borrowed. and it will demonstrate the video output. So that we are now in black-white mode, and that is the checkerboard, and that is the circle that is almost round. Obviously, this is not a 4x3 monitor. If you have a 4x3, a real original one, this one should of course be round. It looks like a little bit not like round, right? And then we got finer lines like that. Then we got the dots, and then we got the resolution checker, where we go all the way up to maximum resolution, and then we got gray scale adjustments as well. If I look at this picture with my eyes, I actually clearly see a white and a gray, and you know, I see all those three here. But if I look at my screen here on my camera, all those three, they look more or less white. So that is probably a camera white balance a problem. But it's in real life here, it's actually pretty good. And this one can very easily be used to reveal resolution in a monitor, in a modulator, demodulator, and video chain, all that kind of stuff. So that is very, very good. A funny thing you want to see here when I switch between the modes, try and look at the distance here, and then you'll see it's actually oscillators that's started at a certain line count. So we have some counters here that count, you know, all the different lines, like 1, 2, 3, 4, 5, 6, 9, 10, and then we start another oscillator that goes tick tock, tick tock, tick tock, tick tock on the white, black here, right? So that's actually how those pictures they are created. So look at that when I go. Did you see that? Doing. See, it goes a little bit until it goes stable. Can you see what I mean? That's because it takes time for all those capacitors and oscillators and analog stuff to actually get to a stable frequency. I think that is so funny. Yeah, what I also wanted to show you is you can combine the different test pictures. So if I take the circle and I take that one at the same time, then you have both of them at the same time. Or this one and the circle. See, you can just combine them. And I can even, well, this one you can't see, right? But this one and that, oh, look at that. See, this one and that one you can combine, and this, then you can see the circle. But I can also take this one, that one, then you got dots and a circle, yeah, and then whatever you want. Isn't that funny? And then the circle, yeah, or that one. If that makes any sense to you, you can do it. I mean, that is really funny. So that's the 5 black and white test pictures. But if we go to color, you're gonna see something funny. They are now all completely changed. It's 5 completely new modes and whatever it is. So this is a half tone red. This is a white, big surprise. This is a PAL demodulation. It's very difficult to pick up on this camera, I'm sorry. But it's actually 4 very special colors for PAL demodulation. And if you're measuring around, figuring out a PAL demodulator, how that one is working, then you definitely want this signal. And then we got the classic color bars. And that is again a frequency tester, and gray scale here with red. And this is probably used for VCR adjustments. I don't know exactly what that is used for in real life, but this is what they say it is supposed to do. Here is this circle generator I was talking about. Let's try and play with turning on and off the circle. Can you see now it's off, and then see? Ooh. Why is it going? Let's just look at the circle, okay? Boing. I mean, that is super funny that it goes like this. So we've got some different voltages used for the different trigger points of the sine waves and all this analog stuff that is around this circle generator, and it just needs to be stable. It's actually very funny to take your hand, I don't know if you can see my hand here, and if I poke my fingers down here in this area. See, this is the pot meter used for size. Where's the other one here? So this one is for elliptical, all that kind of stuff. So yeah, if you touch the pot meters without turning them, you can actually see what they're doing, or you can read the manual. Duh. That is super funny. Oh yeah, here we go. This one with all the different timings, and if I touch, yeah, here it is. See that one? So that pot meter here is that one timing here, and we got the other one. Yeah, see that one? It's also involved with timing. Funny.